Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P1297 specifically indicates an ELD circuit low voltage issue in the 2006 to 2011 Honda Civic. The ELD, or Electronic Load Detector, plays a critical role in managing the vehicle's electrical load by providing crucial data on the current flowing through the charging system. This code suggests a malfunction in the ELD circuit, which can lead to improper voltage readings affecting the vehicle's performance, battery charging, and overall electrical health. Diagnosing this issue requires a systematic approach, as laid out in the troubleshooting guidelines. It is important to note that before diving into the troubleshooting steps, documenting all freeze data and onboard snapshots is essential. This initial step allows the technician to review data relevant to the vehicle's operation during the failure, aiding in more accurate diagnostics. The Electronic Load Detector, ELD, is a pivotal component located near the Engine Control Module, ECM, or Powertrain Control Module, PCM, within the Honda Civic. Its primary role is to monitor the electrical load on the vehicle's charging system and relay that information to the ECM PCM. Proper functioning of the ELD helps regulate the alternator's output and ensure that the battery maintains an optimal charge level. Anomalies in the ELD circuit prompting the P1297 code might indicate low voltage readings affecting various engine functions and electrical components. It is vital to check the ELD's connections, ensuring that no corrosion or loose terminals exist. This component, although small, has substantial implications on the vehicle's electrical health, making it imperative for technicians to address any faults promptly. There are several potential causes of the DTC P1297, each contributing to the observed low voltage condition within the ELD circuit. Firstly, the ELD itself can be faulty, which might stem from manufacturing defects, damage, or wear over time. In addition to the ELD, poor connections due to corrosion, dirt buildup, or loose terminals can significantly disrupt electrical continuity. Another possibility is damaged wiring, whether from abrasion, exposure to the elements, or physical damage, which can alter the circuit's integrity. Identifying these issues requires thorough visual inspections and continuity tests to ensure that every part of the circuit functions correctly. Each of these potential causes must be methodically checked in order to effectively resolve the DTC P1297 and return the vehicle to optimal performance. The symptoms associated with DTC P1297 can affect the overall driving experience in a Honda Civic between 2006 and 2011. A common symptom is the illumination of the battery warning light on the dashboard, indicating problems with the vehicle's electrical charging system. Drivers may also notice inconsistent electrical performance, such as sluggish starting or electrical accessories functioning improperly. Furthermore, weak or dim headlights can be an indication that the ELD is not properly managing the electrical load, leading to insufficient power distribution. Recognizing these symptoms early is crucial for timely intervention, as neglecting them could lead to further electrical failures or battery depletion. Being attentive to these signs can help prevent more serious issues down the road following the diagnosis of the code. The first step in troubleshooting DTC P1297 is to turn the ignition switch to the on position without starting the engine. This action powers the vehicle's electrical system, allowing for diagnostic tools to communicate with the vehicle's computer. Before moving on, it is essential to record all relevant freeze data and review the general troubleshooting information. Freeze data contains valuable information about the vehicle's status at the time the code was triggered, including engine parameters and sensor readings. Reviewing this data aids in understanding the specific conditions that led to the fault, which is crucial for accurate diagnosis. This initial step sets the groundwork for the entire troubleshooting process, enabling technicians to approach the problem with full visibility regarding previous system performance. In this step, the technician will check the Electronic Load Detector (ELD) in the data list using the Honda Diagnostics System (HDS). This advanced diagnostic tool enables the technician to monitor real-time data from the vehicle's systems, including the current output from the ELD. The specific parameter of interest here is whether the amperage reading is 72 amps or more. If the amperage is at the specified level, the technician will proceed to the next step in the diagnostic process. However, if the reading is below this threshold, it may indicate an intermittent failure, suggesting that the system is functioning correctly at that moment. In such cases, checking for poor connections or loose terminals between the ELD and the ECM/PCM becomes necessary to ensure that data transmission remains intact, avoiding false diagnostic readings. Once the ELD's amperage has been assessed, the next step is to turn the ignition switch to the lock 0 position. This step ensures that the electrical system is completely powered down before any components are disconnected, promoting safety and preventing potential electrical shorts. After powering down the system, the technician should disconnect the ELD 3-pin connector from the wiring harness. This action allows for further testing of the circuit while isolating the ELD for accurate analysis. Following the disconnection, the technician will again turn the ignition to the on 2 position and recheck the ELD status in the data list with the HDS. This process is vital in determining whether the low voltage issue lies within the ELD or further upstream in the circuit. At this point, after disconnecting the ELD, the technician will perform another check of the ELD's amperage in the data list using the HDS. The objective here is again to determine if the amperage reading is 72A or higher. If the reading meets or exceeds this threshold, it indicates that the ELD circuit is functioning properly, and the technician should move on to step 7. Conversely, if the amperage reading is below 72A, it suggests an underlying issue within the circuit, requiring further investigation. This could include examining the connections and wiring between the ELD and the ECM/PCM to identify any problems in continuity or signal transmission. These readings provide critical insights and can significantly affect the resolution route taken during the diagnostic process. Building upon previous steps, the technician should turn the ignition switch to the lock 0 position again, after ensuring the electrical system is off. The next action involves jumping the SCS, service check signal, line with the HDS. This step allows the diagnostic tool to perform specific tests while preventing additional codes from being triggered during the troubleshooting process. Jumping the SCS line is necessary as it ensures that the diagnostic tool receives accurate data while performing subsequent steps. This testing process sets the stage for the next critical examination of the wiring and connectivity between the ECM, PCM, and the ELD. Ensuring proper context for these tests contributes significantly to both identifying and rectifying the fault effectively. Following the jumping of the SCS line, the technician should disconnect ECM/PCM connector A, which features 44 pins. This action isolates the ECM/PCM from the circuit for precise testing of the ELD system. The key area of focus during this step is terminal A23 within the connector. By inspecting this specific terminal, the technician can ensure that there are no issues that might be affecting continuity between the ECM/PCM and the ELD. Ensuring the integrity of the connector and terminal is critical before moving on to check for continuity. This step is essential as it helps verify that there are no brushed connections or damaged pathways that may affect the electrical signals and contribute to the low voltage reading indicated by the DTC. In this troubleshooting step, the technician will check for continuity between number A23 terminal on the ECM-PCM connector and the vehicle's body ground. Finding continuity indicates that there are no issues with breaks or shorts in the wiring between these components. If the continuity test is successful, it suggests that the wire connecting the ECM-PCM to the ELD is intact and functioning correctly. However, if continuity is absent, further inspection of the wiring is necessary. This inspection may reveal shorts or open circuits that could be responsible for the P1297 code. Ultimately, the information gleaned from this step directs the technician to either repair the wiring or to take additional troubleshooting steps as outlined in the protocol. If the continuity test extracted from the previous step indicates that there is indeed continuity, the technician should then focus on repairing any identified shorts found in the wiring between the ECM-PCM connector A23 and the ELD. Addressing shorts in wiring is crucial, as they tend to cause erratic behavior leading to diagnostic trouble codes like P1297. Once repairs have been carried out, the technician should ensure that all connectors throughout the circuit are re-established securely and properly to prevent future electrical failures. Proper reconnection of all electrical components helps maintain their integrity and functionality, laying a solid groundwork as the technician moves on to verifying that the repairs have been effective in resolving the issue. After completing the repairs or replacements based on previous troubleshooting steps, the next pivotal action is to reconnect all connectors that were previously disconnected during the diagnosis. This ensures the entire circuit is closed and re-established. Once everything is back in place, the technician should turn the ignition switch to the on position to power up the vehicle's electrical system without starting the engine. At this stage, resetting the ECM-PCM with the HDS is a critical follow-up step to clear any existing codes and allow for fresh monitoring. The technician should then check the system using HDS to look for any pending or confirmed DTCs. This step validates that the repairs were successful and that the vehicle's electrical load management is functioning correctly. To ward off future occurrences of DTC P1297, regular preventive maintenance is paramount. Technicians and vehicle owners alike should regularly inspect connections related to the ELD and the ECM-PCM to ensure they remain clean, tight, and free of corrosion. Additionally, routinely checking the operation of the ELD can help catch problems before they escalate, ensuring consistent electrical load management. Maintaining the integrity of wiring and connections throughout the vehicle is equally important, as any wear and tear can lead to issues down the line. These maintenance checks serve not only to extend the life of the components involved, but also to enhance the reliability of the vehicle's electrical system. Proactive measures help to prevent unexpected failures, ensuring a more safe and effective driving experience. In conclusion, addressing the DTC P1297, which indicates an ELD circuit low voltage issue, requires a systematic approach to troubleshooting and timely repairs. Start by examining the electrical connections and ELD's functionality before proceeding to deeper diagnostic steps involving circuit continuity and connections. Each step in the troubleshooting process builds on the previous, leading to a comprehensive understanding of the issue at hand. Ensuring that repairs are made and followed by thorough testing is crucial to validating the resolution of the problem. Prevention, through regular inspections and maintenance of the ELD and wiring, enhances the vehicle's overall electrical health. Proper attention to these details not only resolves the current DTC, but also helps in avoiding future complications, keeping the Civic running smoothly. Please like and subscribe to the channel. See you next time.